Welcome to Homeschool Nolan, here to help you navigate learning in a digital age. Today I'd like to talk about how linear algebra rules the world. You see, when I first studied linear algebra at Princeton many years ago, I never thought about what it was used for. I still remember one of my classmates complaining after class how the subject was so abstract. Even though we were both engineering students, it wasn't clear to us at the time what these matrices, determinants, and eigenvectors were used for. Well, fast forward to today. AI and machine learning are now promising, or some would say, threatening to take over the world. But underneath the hood, these machine learning algorithms are using linear algebra to analyze and train from data to rule the world. Now, I'm not going to try to offer a crash course in linear algebra in a 10-minute video. But what I'd like to do today is talk about a few examples of how linear algebra is used to solve important problems, particularly in artificial intelligence. So, if you're studying linear algebra today, hopefully you'll have a better appreciation for what it's used for. But first, what is linear algebra? Well, linear algebra is that branch of mathematics that deals with vectors and matrices. Now, what's a vector? Back in high school physics, I learned that a vector is like an arrow. It has magnitude and direction. But a vector is also really just a list of numbers. Vectors are foundational to data science and machine learning because all the numbers used to represent data, text, and images can be organized or put into vectors. And when you have rows of vectors, you create a matrix. And linear algebra gives us the tools and techniques for analyzing vectors in matrices. Now, one operation on vectors that's very useful is called the dot product, or sometimes known as the inner product. It's used to find how similar two vectors are to each other. If two vectors are orthogonal, their dot product will be 0, and it means they're completely different. But the more similar they are, the bigger their dot product, and the bigger their dot product, the more similar they are to each other. Now, dot products are a great tool to finding how similar two things are to each other, and they're used in recommendation systems. So the next time you get recommended to read or buy something online, you can think linear algebra and dot products. The main concept, though, that I remember from linear algebra is the determinant. The determinant is a single scalar number that you can calculate from a matrix. Now, the rule for calculating the determinant is actually pretty simple and straightforward, but I never really knew what it was used for. And to tell you the truth, I still don't know what it's directly used for. But I do know that the determinant is used to find two other important concepts in linear algebra, and they are eigenvalues and eigenvectors. If you've studied linear algebra before, you may recall that the eigenvector of a square matrix are those vectors that, when transformed by the matrix, are stretched by a scalar value. In other words, when a matrix is used to transform one of its eigenvectors, that eigenvector is either made longer or shorter, but it is not rotated. And the amount it is scaled by is called the eigenvalue. So what does this all mean? Well, eigenvalues and eigenvectors are very useful for a powerful technique in machine learning called principal component analysis, which is a technique for dimensionality reduction. Now, what does all this mean? Well, this is all used for narrowing down and finding the most useful features of a data set. For example, let's say you wanted to use machine learning to predict the price of a home. Now, examples of features that can help you predict a price of a home are its square footage, zip code, and maybe the color of its carpet. Now, I think most of us intuitively know that the square footage and zip code of a house can influence its home price. But what about the color of its carpet? Carpets can be easily changed, so I think we know that the color of its carpet probably won't have as much impact on its home price. What PCA and dimensionality reduction do is they find the features that are most useful and eliminate the others. So in this case, we could use it to narrow down that the square footage and the zip code are more useful than the color of the carpet. And eigenvalues and eigenvectors from linear algebra are mathematical tools for performing this technique. Beyond machine learning, linear algebra is useful for many other applications like computer graphics, data science, and solving practical problems in engineering, physics, economics, and pretty much any field that deals with numbers and data. The problem many students have when they study linear algebra for the first time is that it's not obvious what all those techniques on vectors and matrices are used for. And I hope this video has given you a taste of the power of linear algebra. By the way, if you're looking for an online class on linear algebra, check out study.com. Study.com has over 8,300 engaging videos, including courses in linear algebra, calculus, statistics, and other college-level courses. I use it with my son, and we find it a great way to support his homeschooling as well as my own supplemental learning. Use the coupon code HomeschoolNolan and get 30% off the first 3 months. Check out study.com today. People sometimes ask me whether they should take a particular course in data science or coding to help them land a job in tech. I always tell them that when it comes to tech, it's always difficult to predict exactly what will be hot 5 to 10 years from now. What they should do instead is focus on the fundamentals. If you have a solid foundation in mathematics, all the latest trends in tech will be much easier to pick up. So, if you're interested in a career in AI or any other field that uses data, I highly recommend studying linear algebra. And I hope this video has made the subject a bit more interesting for you to learn. Let me know what you think in the comments below. And don't forget to click subscribe for more videos like this one. Thank you for watching. I'll see you next time.